To understand how a Kubernetes cluster works, it helps to picture a bustling, highly organized city grid. Inside this city, your applications are constantly being assigned to different neighborhoods based on traffic and available space. The most common type of application you will run here is known as a deployment. Because deployments handle standard web traffic, they operate entirely without memory. They are stateless, acting very much like pop-up food trucks that appear whenever and wherever hungry customers demand them. These food trucks are perfectly interchangeable. If one of them suddenly crashes or runs out of resources, the city planners simply delete it and instantly spin up a brand new replica on a different block. Because the truck doesn't store any permanent customer records, nothing valuable is lost. That flexibility breaks down the moment we introduce a database. A database holds your permanent, critical information, user accounts, financial records, and transaction histories. It simply cannot function like a disposable food truck. If a database was treated like a standard deployment and Kubernetes randomly cloned it to handle more traffic, the system would immediately lose track of which copy held the true, up-to-date information. This triggers a split brain disaster, with two identical databases shouting over each other and causing instant data corruption. Deployments are perfectly built for handling fast, high-volume web traffic, but to protect data-heavy applications, we need a structure designed for absolute permanence. That brings us to the StatefulSet. If a deployment is a disposable food truck, a StatefulSet is a heavy brick-and-mortar bank. It trades speed and flexibility for strict rules that keep data perfectly intact. The first superpower of a StatefulSet is stable identity. While food trucks have randomly generated, constantly changing license plates, each pod in a StatefulSet is assigned a permanent sequential name, like Database 0 or Database 1. To make sure applications find these buildings, Kubernetes creates a Headless service, a permanent phone book. If a database pod crashes, it restarts with the exact same name and network address. The city always knows exactly where to route data. The final safeguard is strict deployment order. A StatefulSet will never launch its pods all at once. It builds them sequentially, meaning the second bank is entirely blocked from starting construction until the first one is fully operational and healthy. This careful step-by-step sequencing is exactly what complex data systems like PostgreSQL or MongoDB require to synchronize their storage safely without losing a single record. StatefulSets sacrifice the lightning-fast scaling of a standard deployment, but they provide the rigid safety and predictability required to anchor your most valuable assets. Underneath all these applications are the physical servers themselves, the nodes that make up the actual concrete blocks of our city. Maintaining these physical blocks creates a new challenge. We need to ensure that essential background tasks, like security monitoring and system logging, are running evenly across the environment. If you try to use a normal deployment for this, Kubernetes simply looks for available resources. It might clump all of your security tools onto a single server that has free memory, leaving the rest of your city blocks completely unmonitored. To fix this, we use the city's utility infrastructure, the DaemonSet. You can think of a DaemonSet as the streetlights on a block. A DaemonSet overrides normal resource scheduling, forcing a strict rule. Kubernetes places exactly one copy of the application on every node. It scales automatically. If you plug a new server in, the DaemonSet instantly installs a worker onto it. Operations teams rely heavily on DaemonSets to run tools like Fluentd for gathering system logs, or Prometheus node exporter to track exactly how much CPU and memory each server is using. They operate as the invisible glue of the cluster, ensuring every physical server is equally monitored and managed entirely automatically. When we step back and look at the fully functioning city, we see each workload type thriving in its proper zone. Deployments handle the unpredictable, high-speed web traffic, using stateless, disposable replicas that instantly scale up and down on command. StatefulSets safely anchor the databases, utilizing permanent identities and strict deployment rules to keep data perfectly synchronized. And DaemonSets blanket the physical servers, placing exactly one critical utility on every node to provide universal coverage. By matching the right tool to the right task, a chaotic environment becomes a reliable, automated infrastructure capable of securing any application you build.